In this presentation, we will talk about state machines and how a blockchain can be seen as a state machine. First, let's define what this is. A state machine is a model that we can use to represent most systems, especially the digital services built on blockchains. While it may sound technical, it's crucial to understand how state machines work as they form the foundation of how we model systems in a blockchain. A state machine consists of a set of states and a set of rules about how transitions between those states occur. These transitions can happen when someone interacts with the system, pushing a button, making a request, or performing an action. Let's begin by walking through how we can represent systems using this model. Let's imagine a label transition system that maps out all the valid states of a system. For example, in this diagram, you can see 4 states, A, B, C, and D. The arrows represent transitions between those states. Some transitions are straightforward, like moving from A to B, while others, like from D, can go in multiple directions, making the system non-deterministic. In practice, only the simplest state machines can be fully mapped out like this. Most systems are too complex, requiring us to represent states with internal data fields to manage all possible transitions. To illustrate this, let's look at a simple example, an audio amplifier. Imagine an audio amplifier with 3 buttons: louder, quieter, and mute. The amplifier can be in one of 4 states: silent, quiet, normal, and loud. When you press the buttons, the amplifier transitions between these states. For instance, if it's in a loud state and you press quieter, it moves to the normal state. If you press mute, it goes to silent. Now the tricky part is what happens when you press mute again. The system needs to remember where it was before muting, so it can return to that state once mute is toggled off. This is where state machines can become more complex. With just 4 states, it's not enough to capture all the transitions, so we need to add more states or track internal fields like muted from loud or muted from normal. Now that we've covered that example, let's look at another, simpler one, a light switch. It has 2 states, on and off, and a toggle button to switch between them. The history of this state machine is easy to track. It starts in one state, the button is pressed, and it transitions to the other state. This simple concept will help us understand more complex systems like digital cash and social media platforms. Digital cash systems like Bitcoin are designed as state machines where each transaction is a state transition. The idea is that anyone can spend their money and each transaction is recorded in the system's states, reflecting the flow of money between users. But state machines can model much more than just money. Take social media, for example. In this system, the state includes every post, comment, and like. As users interact, posting comments or liking existing posts, the state updates with each transition, just like in the digital cash example. All these examples, from an audio amplifier to a social media platform, can be modeled as state machines. They help us represent complex systems in a formal, understandable way. This brings us to a key idea. If we all agree on the starting state and the history of state transitions, then we must all agree on the current state. This is fundamental to blockchain systems. In blockchain, we call the starting state the genesis state. It's the first block in the history of a blockchain. This genesis block forms the foundation for everything that follows. From there, the blockchain tracks all the transitions, ensuring we can all agree on the current state of the system.